we sent our children to a Waldorf school or a Steiner school, and the thing that I love about that system so much is that Rudolf Steiner saw everything connected, like Leonardo da Vinci did here. Yeah. There's no difference between visual arts and hydrodynamics and mechanics and biology. It's all just another way to observe the same subject matter.
Yeah, basically, if you're talking strictly about academic studies, to be honest, they were really focused on mathematics. So all the other analogies with nature, you do them by your own.
I hope this to be the case for my grandchildren and so on. I think that we can care about mathematics in a way that is missing from a lot of our education.
I can state that if I wanted to reform the education in the academic engineering world, I would put something much more practical and much more connected to everyday world instead of doing purely mathematics.
Today's episode of Life with Strings Attached was filmed on location near Bologna, Italy. Giulio Di Donato is an aerospace engineer from Venice, Italy, currently living in the suburbs of Bologna. A lifelong passion for mathematics, physics, space, and race cars led him to pursue aerospace engineering, specializing in aerodynamics and thermal management at the University of Padua, a prestigious institute in continuous operation since 1222, making it one of the oldest universities in the world. In 2012, Giulio started working in the automotive industry for an iconic super sports car company's research and development department. It's interesting to note that he was the first aerospace engineer they had ever hired, as super sports car innovations demanded a specialist in aerodynamics and thermal management to increase their competitive edge. He is responsible for the thermal management of the vehicle from the early concept phases to the design and development in CFD, or computational fluid dynamics, to the testing and final validation on track. He is extremely passionate about music and high-end sound systems, both with commercial products and do-it-yourself loudspeakers and amps. And he shares my love of traveling and discovering new cultures. I learned a lot in this conversation that's had me thinking about new concepts to be applied towards my work. I hope you enjoy it as much as I did.
Giulio, thanks for having us here.
Thank you.
Thanks for taking the time. This is I've been looking forward to this conversation since we spoke last September at the Venice Biennale. I think it's the first time we had any serious conversation together, although we met, I think, in 2017, but at a very busy show.
Yeah.
And we didn't talk very much then, but I thought, well, first of all, I think you're a kind and fascinating person. And you have experience in education, which I'm hoping to learn from, frankly. I'm here to take. No, that's not true. I want to give also, but a core concept of what we do is that we're better together. And so we're always looking for cross collaborations and how we can learn from each other, and the language set that different people use with different experiences and different education. And so your work within physics and with aerospace and such is really fascinating to me, because in my work, people talk about, we often talk about the air as this elusive thing, the kind of nothingness. Even though I can feel the breeze in my face right now, I can't see it, and so, we can feel the effects of the wind, but we don't see the wind necessarily. And so, I would like to understand that a little bit better, and I would like to understand it as I gain competency, as I think about the most concrete things being the solids around us. I think we feel like we understand them best, and then liquids we understand a little bit less. And I think the air we understand a lot less, as far as the average person is concerned. And so, as a matter of fact, when I said the air to you, I second-guessed myself. I said, am I calling it the right thing, or what do we call this?
Yes, basically. Well, if you're talking about the Earth atmosphere, we speak about air.
About air.
But of course, if you're thinking about another planet, if it has some gaseous atmosphere,
yes,
we can
atmosphere.
Talk about atmosphere or gases or.
Yes. I like the gases because it makes me conscious of the fact that it is something. as opposed to the nothingness that I sort of described. And actually, I've never talked with anyone else about that. It's my impression, but maybe everyone else thinks of it as something, and it's just me. I've been the lone ignorant person on the planet who thinks of it as nothing. But I'm operating on the assumption that most people really think of it as kind of nothing. And so, but before we dive into that kind of discussion, I know you through your brother Enrico, who we've known for a while, and that's what this podcast is about. It's a life with strings attached. It's the people I meet because of guitar that I should otherwise have no business knowing. There's no reason my work or experience should connect me with an aerospace engineer, but somehow my experiences with the guitar, and in this case ultimately the Venice Biennale, is where we had enough of a conversation for me to get a glimpse of what you're doing that led to this conversation here. And that opportunity was because of the guitar. And my architect friends, when I told them that we were doing something at the Biennale, they were almost indignant. They're like, how the fuck did you get invited to the Biennale? You're the guitar guy, right? And they had gone to the right schools and done the right things and had never been invited, As a matter of fact, even your brother Enrico, because I invited him to be part of panel discussions. I mean, you guys are Venetian. And he was like, seriously? It takes a Canadian to invite me to to the Venice Biennale? But that's the amazing thing that keeps happening in my life. And I suspect you could say the same thing. So I know that you're very well traveled. And you've been to a number of countries, which I have not, which is super interesting because I want to go everywhere. Okay. And so let's just, for the benefit of our audience, let's take it back for a moment and say, all right, so Giulio Didonato's Italian.
Yeah, I'm Italian.
And so just give us a glimpse of what brought you to this point in your life. You were born in Venice or somewhere?
We were born near Venice, yes. By the end of the 80s. My childhood was quite normal. I grew up with Enrico, who I remember was a great big brother. And well, basically, let's say I started developing myself when I started to go to the university. I studied in Padova, aerospace engineering, as you mentioned.
Yes.
And right after the graduation, I started working for a super sports cars manufacturer here in the closeness of Bologna. And from there, I developed all my experience and knowledge about the physics and the other things about aerodynamics and thermal management. That's it from the
growing up in the education side.
Yeah, education side.
In one of my recent trips here, Padua, I think, is quite famous in Italy, but on a global scale, it sits in the shadow of Venice, I think. And I understood that university is the second oldest university in Italy. It's about 800 years or so.
Even more, I think. Even more? Something more, yes. Yeah. It's the second most oldest university in the world.
In the world.
Basically, yes.
Yes, and I was just there in my taxi cab. They were letting us know the first female graduate from a university in the world happened there, also in Padua. And one of the funny little stories I like to tell is, Enrico also went there, and he gave us a small tour, and we're walking away, and I looked at a bust, a small statue, and I said, "Hey, that says that's Galileo Galilei, right?" And he's like, "Oh yes." I'm like, did he teach here? He says, "Yes." I said, "You didn't think to mention it? It's unimportant?" He said, "Oh no, it's yes, no, it's important." But that's what happens all the time when I'm in Italy, because there's just so many significant things that happen within Western culture in this place that the people who tour me around often miss what I think are very significant things because there's just too much to remember.
That's right.
Yeah, and so I really enjoyed my time in Padua. And your time there in the university, did you know you were going into aerospace when you got there, or did you start in a less specific science?
No. I started specifically in aerospace engineering. And actually, this is one of the things that I regret. Basically, I didn't actually live in Padua while I was studying. While I was studying, I actually, since we lived a few kilometers from Padua, I was doing commuting
Stayed home
every day. So probably during those years, I missed some of the, some of the things you described about realizing where I was studying and all the story that was behind it.
Yes.
So I saw the university just like a place where to go, take a lesson, do exams, and come back home.
Yeah.
I started appreciating Padua after I graduated, after I moved here in Bologna, and when I came back to my families, I really started appreciating Padua much more.
Yeah. Well, this is only our second or third time in Padua. Sorry, this is, we're not. I'm in Bologna. But I was there this morning. I woke up in Padua and I've been there for the last days. and I really enjoyed it. My son, Zach, he's a big history buff and also likes mechanical objects and watches and things. And we were sitting in the town square and he said, "That's an astronomical clock." Yes. He said, "There's only a few of those working in the entire world." And he happens to live in Strasbourg, where one of them happened to be in existence still too. And so those are fascinating objects to see inside these huge geared mechanisms that are running down to I don't know how often they're tuned, but they're running down to the second that makes a turnover on the month, the day, the year, through gears and reducers and
that's really interesting because
shafts.
Apart from the engineering, you need to understand the physics, different level of physics. The first one is, of course, the natural phenomena and the astronomical thing. You need to understand how the planets and all the season, how the season comes and goes. This is the first level. Second level is how to design something which is able to recreate somehow this movement of the planets and the season and so on. And then the third level is actually to manufacture everything to the smallest gear in those past years with such precision, and there's different level of complexity.
Yeah, with the tools they had. Now the grand understanding, it brings to mind that I didn't do a lot of teaching of musical instruments, but we owned a music school, and there would be times where something would happen. A music teacher would get in a car accident or had some problem, and they weren't going to make it to teach the students, and I would, as the owner, step in to teach the students. And I remember in this time, the band Muse had this song that was really, really popular, and this young teenager came in, and this is a really complicated bass line. I'm forgetting the name of the song now, but it has sort of 16th or 32nd notes, and he was so tight in his technique because he saw the song as and he tried to maintain that for 3.5 minutes. I was like,
relax.
These are part of something. And so I need you to hear this as, down, 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 da 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 da, bum, 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 ba da ba da bum. So I mean, breathe, move. This is a small movement within larger movements within a larger movement, and we had to talk about not just the single notes, but the bar and the whole movement in that particular verse within the context of the song. And can you hear now that this is actually a 16 division of? But I realize how often people are focused just in that little minutia, and the part that you bring up so clearly was that they needed to understand the movements of the planets in order to make these gears run in time, and that's that's the way that I hope to understand most things. That's why I'm so curious. Why I have so many questions? Because I want to understand. I want to understand that, and so, I mean, hell, I'm going to dive right in. So, one of the things I want to talk with you about is I have been trying to understand sound because I work with guitars and other musical instruments. I'm a drummer as well, and different things, but I've been trying to understand sound in the simplest way possible to remove the limitations and to test the assumptions. And for me, I've gotten it down to 3 words, 3 concepts, and they are movement, because energy and movement are one and the same when it comes to physics, and that we cannot create or destroy the energy. It just exists in different forms, right? Often we put something in motion and we now have a kinetic energy that dissipates through a thermal reaction of some sort. Often it's a simple form to understand. And then we have time. And time, because that's how we measure the movement. We have to agree upon that it starts somewhere and ends somewhere, so we can count what happens between these moments. And so time in purposes of sound, we measure in hertz, because of a German scientist. I forget his first name. Last name Hertz. One movement, 1 second, 1 hertz. And then the A string of a violin is 440 movements within 1 second. And that's where we have the A440 sort of concept that we tune all of our musical instruments to in the Western world. So we have an agreed upon time. And then the last part actually is perception. Because without the eardrum, for us, it's just energy in motion. It's actually translated to sound when it interacts with the membranes of our eardrum and to our audio perceptors. But motion plus time is also light when it interacts with our eyeball. It's smell, it's taste, it's touch. All of our senses are ways that we engage our physical reality and are able to perceive them with the motion and time. Does that make sense?
Makes sense.
So the reason I want to understand it this way is because when I hear something, and we talk about bass or low frequency and treble, high frequency, mid-range frequencies, I begin to understand that the tensioned object of a guitar. So again, we have energy and things that have potential energy, and a tensioned object is something that has potential energy, which is a guitar in our case. And so when I hear certain sounds of an instrument, I say, I want more low frequency. I need to figure out how to make less efficient sometimes, or insert time into the system somehow, which might be thinning the membrane at the top, so that the same amount of energy causes it to travel further. You get a greater amplitude. It might be bringing a longer dimension or grain, because again, a short bar has little movements. Long one will have a greater amplitude, again, like a marimba. And so I found this to be a very useful way of thinking about things when it comes to the musical instrument. And when it comes to automobiles, which is the area that you've been working in, the thing that I find so fascinating is that guitar is wrapped up in icon. And because of the icon and a time period, it's wrapped up in 1950s technology. And there is not a strong push to move the guitar forward with technology. But you're in such a highly competitive marketplace that the companies, like the company that you work with, are trying to shave a fraction of a second off so they can beat someone else. A fraction of a second makes you better. That doesn't exist in guitar in the same way, and it drives innovation. And so when I talk about a tensioned object, and that to get this insert or remove time, do I want it, we do so by either making an affordance so we can move the energy in that direction by freeing up the system, or by making an obstacle so we don't lose the energy in that direction. We will do that through more dense woods or less dense woods, through changing the membrane thickness, all of these things. And I think that must be the same thing when dealing with automobiles, or else it would shake apart in some areas. You must be making obstacles and affordances as you try and move through. Is that an oversimplification of
No,
this?
I really like the idea of making obstacles and making like
Affordance.
preferential direction,
Yes.
because this is the same way that we do in aerodynamics.
Yes.
In order to make the air when the car is moving where we want, we just create some obstacles to say, okay, no, we don't want the air to go in this direction, and we make some other channels, to make the air flow in that direction, so that we are able to use it for cooling, for downforce, for lift, or for our purpose.
Yes.
So it's a different physical phenomenon what you described, but the overall principle, I think, is the same.
Yes.
To direct the energy, and this is
Yeah.
even a bigger statement.
Yes. I recently saw probably on Instagram, a race between a modern Corvette and an old Volkswagen Bug. And the Volkswagen Bug was really keeping pace most of the time and often winning, off moving ahead, until they came over this hill. And the Bug went, the front wheels went right up, and the Corvette kept down over the hill, and boom, that's where he took it. He actually took it. So when you mentioned the downforce, this Volkswagen Bug didn't have it. It went right up in the air instead of staying down.
Yeah.
And high performance cars, I mean, we look at them and it's so obvious where the direction is, because often there's really obvious intakes on the sides of the car, and the fronts of the cars are often so like a wedge, just cutting through, I presume. Yeah. So I'm presuming you're not using the same words that I'm using. How do you think on a astronomical scale, let's say, because we talked about the clock, and you said that's amazing, because to make the gear, they also needed to understand, well, not to make the gear, but to make it correct and precise in the system. So how do you view what you do in the simplest of terms, on the highest level?
That's a really tough question, because never think about it.
No?
No, because we are much more focused on the small gear, the small detail, like we discussed. And to make a step back and see things from much above and see the overall picture it's not easy for an engineer sometimes. So
Cedar Creek Custom Case Shop is your premier fretted instrument custom case maker, and we invite you to create a musical instrument case unlike any other, one that's unique to you. Every Cedar Creek custom case is hand-built by highly skilled craftspeople using only select woods, Prominence Forge hardware, and premium instrument-friendly materials. At Cedar Creek Custom Case Shop, we are dedicated to helping you design the case of your dreams. Find out more at cedarcreekcases.com.
If your nephews, if young Pietro wanted to understand what you do, how would you explain it to him?
I will draw something, probably.
Okay.
I will draw a car.
Yes.
I will draw normal shape of a car. And then I will make him think about, okay, now start thinking about the car is moving in the air, something that we don't see.
Yes.
And we need to make it work so that we can make the car does what we want to do. And so I start explaining him that probably it's difficult.
What question might a child ask? So Giacomo's hearing you say something to Pietro. What does Giacomo say?
Yeah, they probably ask me how fast the car will go.
Yes.
Yeah, so this is actually a good question because how fast the car can go is related to how aerodynamics it is. So how the drag coefficient, so the resistance that the car is doing to the air is low. The lower, I guess the velocity, the speed the car can go. So this will be like a great question from my nephew to start explaining him what's the purpose and what's the role of aerodynamics. So to make the car more efficient, to cut better. So this would be a good metaphor maybe, to cut better the air and to make the car go faster. But to explain an overall picture with just some few words, it's difficult. Yeah, probably it would be easier if the kids, my nephew, will do some questions to me and then
and you get to answer.
Yeah.
You know, as you're talking about cutting through the air, I remember in a story that my children listened to when they were young that I really loved. Also, I learned a lot from it. And it's this sort of mythical, magical sort of realm. And there's a moment where the great hero is given, he loses his sword and he's given this magical sword, and the witch who gave it to him said, be very, very careful, you know, because you can cut your leg off with this thing. And she tells him to cut through a marble table. I said, what? And he went so hard because it's marble, and it just, like the table didn't exist, and almost cut off his leg. He said, whoa. And he says, what is happening? I don't understand what's happening. And she doesn't give him a physics lesson. She's a really brilliant person, but she says, basically she describes a little bit of the ultimate inclined plane, and says, once you'll understand that, come back to me, you know. But the ultimate inclined plane could fit between any matter, right? And so is there a point when you're trying to cut through the air where you do not want the plane inclined anymore, where it becomes actually less efficient to do that somehow, or creates another problem?
Well, actually, we are not cutting through some solid metal, so you need to actually have a really sharp edge.
Yes.
If you're talking about the subsonic velocities.
Yeah, in your aerospace and in your work when you're moving through the air.
The best way is to have a smooth shape in the front in order to have a better penetration and a lower resistance. If you make some really sharp edge, there will be some air separation, you will create some turbulence, and it will be the opposite effect. It will have the opposite effect.
Okay. What is air separation?
Separation is when, there's the air which is flowing through a surface, and it follows the surface.
Yes.
If there is a too sharp edge, it goes this way, and then here start to detach from the surface, and there are some vortex, and this will create separation of the airflow, and increase the resistance of the body in motion.
Because there's a back pull with the vortex?
Yeah, basically some resistance and energy dissipation from this vortex, which will create some resistance, both in shape
and then some shaking,
and also
the turbulence, you say?
Yes, on some level, will lead some shaking. Or probably the von Karman vortex, which are, you know them?
The which vortex?
Von Karman.
No.
It's a name of...
I do not know.
No. So basically there are some, which is somehow related also to structures and building bridges and so on.
Okay.
So when there is a big pylon or a big rope and the wind is blowing this direction, there are some detaching vortex from the pole.
Yes.
And this creates some forces and some resonation to the pole. And this in the past created some big failures also to bridges, which are
Tension
some
bridges?
yeah,
Okay.
because the windows was blowing, was creating some
Yes.
resonance, and was breaking apart the bridges. So
Okay.
somehow the air
Yes.
can cause, also from wind instrument,
Yes,
can
not
cause
just wind
vibration.
instruments. I mean, we are intentionally setting those ropes, the strings, the chordophone, in motion on a guitar. And I've never thought about the separation and potential small vortexes. Is this happening on the scale of a guitar? Is this causing some small?
Yes, always happens,
Always happens.
but it's negligible basically for the
Yes.
purpose
The amount of power
guitar
is irrelevant.
playing and guitar making. I think so. Yeah.
Okay. Yeah.
I mean, it also depends on the density of the air or the gas in this
Yes.
case. If you're talking about the normal density here, it will work basically like without any impact. If you are considering another gas which might be heavier than air, could probably do some more impact. Think about also some videos that you saw online with people inhaling helium,
Yes.
having the
Yes.
small voice, and then inhaling another gas, which is really heavy,
Drops
and
the
they have
pitch.
the big voice.
Yes.
So in the same way, depending on the atmosphere, on the gas, it could also have some impact, but it will be really, really small.
So that's the gaseous effect. I always presumed that was doing something to the membrane. It's not the membrane, it's actually the density of the helium is not causing a physical reaction with your...
No,
membranes.
no chemical reaction. No, it's just the density of the
Yes.
gas, which basically it's like
It's a lower density,
helium. Yes, lower density. Think about
so there's less resistance than,
yes.
than the mixture that we normally breathe with the oxygen.
You can
nitrogen,
also
carbon.
make a parallelism between what you said before about the density of the wood
Yes.
and the thickness of the wood.
Yes. Exactly.
Works almost in the same way.
Well, so we've with the helium then the density is less, but it's moving faster, higher pitch. I'm gonna have to think on that in a little while, but I will be thinking about that. Thank you. I'm gonna shoot up at 4:30 tomorrow morning with a word on my mind. But that's wonderful. So this concept of air separation is really interesting. So you don't just want to cause it to cut through it. You actually want it to somehow
Flow around.
flow around it, but to stay in contact.
Yeah. For different purposes. The first one is the decreased resistance
Yes.
because of no separations and no energy dissipation.
Yes.
The second one will be, okay, if you have the air which is attached
Yes.
in front of the car, for example, you can manipulate where you want it to go after.
Yes.
So there's a double function.
Yes. Cause it to flow. And so what are the other benefits of keeping it and then directing it? Where else would you want to direct it?
Oh.
You mean into the intakes? Or
The first idea will be, yes, into the intakes for
Yes.
cooling
Yes.
the radiators and so on. The second option will be to direct into wings or some other part of the car which is responsible for creating some downforce, like we said before.
is that part of the spoiler at the back of the car?
Yes, that's
That's for some downforce?
Yep. And
And you do that by causing some separation or not? Or by... because this is above,
Mhm.
and so is it directing the same air that's staying over the front of the car, or it's gathering something more? What is the spoiler effect? What is happening?
Yeah. Basically, if it is a normal spoiler, like something which it's called ducktail because it reminds of the tail of a duck.
Yes. Yeah. Okay.
Yeah.
Yes.
It is something like this. Basically, will collect also some air from the outside of the outer layers of
Yes.
the air, which comes from the car, and will basically do a shape like this movement.
Mm-hmm.
And so by going up, it will create a reaction
Mm-hmm.
in the towards the ground, and that will for
A vacuum-like reaction, or what? It's not a vacuum. What's
in this case, it's not a vacuum if it is a spoiler. In
Yeah.
case we are talking about a wing, there
Yeah.
will be a vacuum reaction, yes. But if it is just a spoiler, like it is attached to the car,
yes?
it is just a downwash effect.
Downwash.
Upwash, and therefore a
Often the
downforce
opposite
effect. Yeah.
response. Yeah.
If you're talking about a wing, most people think that they works by pressing down from above. They press down,
Mhm.
while they function basically by vacuum the lower side
Yes.
and sucking down.
Okay.
So yeah. Also related to this, there are also different design issues in order to make wings work better.
Mhm.
Which basically you need to also attach the wing to the body of the car in order to connect and direct the force to the ground.
Mhm. Mhm.
The easiest way will be to support the wing by the lower part,
Mhm.
like this.
Yes.
But in this way, you will disturb the part of the wing which is actually working in creating the force.
Mhm. Mhm.
The ideal way will be to take the wing by the upper part.
Yeah.
So you have the gooseneck design of
Okay.
the wing and the pylons.
Yes.
So this will influence also the design of the car, depending on
Mhm.
how much you want to achieve and if the design is really willing to do in that direction.
Mhm. Mhm.
This is something that you find mostly in really race cars,
Yeah.
not sports car.
Right. Right. Now, in two scenarios there, you referenced waterfowl,
What?
birds, ducks, and geese.
Yeah.
Is that a large part of studies of aerodynamics, the referencing birds in motion, or
During my studies, you mean?
Yes.
No.
no?
No, if
Really?
Really,
It
yes.
seems like why not? That's
I don't know. It will have been really interesting because that's the main source for inspiration, nature.
yeah.
But actually, if I remember, a lot of mathematics, a lot of formulas and so
Yes.
on, but no real connection with nature. It's
So
strange.
biomimicry is something that really fascinates me.
Mm.
You know, we were just in Japan last week. This time last week, I was still in Japan, and these really high-speed trains, they were having problems with a sonic boom when they entered the tunnels or when they left the tunnels. Either way, entering the tunnels, and which was going to compromise the structure of the tunnels over time, just like those bridges with the little vortexes on the ropes that you were talking about, and which, by the way, now kind of scares the shit out of me.
You know,
Because we make this very long tensioned rope bridge from Copenhagen to the south of
Yeah.
Sweden every year.
now they take into account also those phenomena.
I'm sure they do, but I will definitely be thinking about it as I'm crossing many kilometers over this bridge over the sea.
The one in Malmo, you mean?
The one in Melbourne, exactly. You know where I'm talking about. And we do this drive from Copenhagen to Malmo pretty much every year in a motorhome. Not a very nice aerodynamic car. So, but biomimicry with these, I mean, I'm sure it's a very famous story, so I'm sure you know it. You know that they look to the kingfisher, this bird which so amazingly dives into the water and such an efficient hunter, and then leaves the water so quickly again. And that's what helped them solve it. So they really elongated the front of this train. And I watched something about a desert beetle, which has a design on its back and small nodules, that the beetle is remaining under the sand in the daytime and becoming hot. And when it comes up at night, it has the heat, and the desert wind is carrying moisture that the beetle's carapace removes from the air, and water droplets build on its back, and then its back has this channel that comes down around its neck, and it drinks. It draws the water from the air, and they made a scientific observation station in the desert using what they learned from this beetle, and to see could they draw enough water from the air. And they drew so much water from the air they had to dissipate some outside of the building, and now there's a green ring growing around this building in the middle of the desert.
Yes, beautiful.
And so the idea that you can get a degree in aerodynamics and never touch on nature, please don't get me wrong, I'm not trying to say your degree was a bad degree. It's just baffling to me because we sent our children to a Waldorf school or a Steiner school, and the thing that I love about that system so much is that Rudolf Steiner saw everything connected, like Leonardo da Vinci did here. Where there's no difference between visual arts and hydrodynamics and mechanics and biology. It's all just another way to observe the same subject matter. And so studying aerodynamics without ever talking about birds. All right, I'll get off the topic. But I'm just so surprised. Do you personally have interest in...
Yeah, basically, if you're talking strictly about academic studies,
Yes.
To be honest, they were really focused on mathematics. And so, So
Yeah.
all the other analogies with the nature, you do them by your own, by doing some personal research,
Yes.
by watching movies, documentaries, videos about what you're really passionate about.
Yes.
So reading books and so on. So it came in parallel and also later after graduation, all this, but also before,
Yeah.
during high school and so on. But the real academic studies were focusing only on mathematics.
Mathematics. And did it have a I'm struggling for the word. I'm going to say reverse effect. I don't think I mean reverse effect.
No.
But did you come into the mathematics, and do you see the world around you? Do you see nature differently because of your depth of understanding in mathematics now?
Some phenomena, yes. Yeah. And also something which are purely mathematics, and while you are studying them, you are saying, how will it be useful for me, this thing?
Yes.
Then you realize that not in the everyday life, but in the working life, sometimes they do return useful to you. So yes, overall, I will say it was too focused on mathematics, but then again, it was also somehow rewarding.
Yes. Oh, I'm sure, and I don't mean to suggest otherwise.
No, but from also my point of view, after 12 or more years,
Yeah.
I can state that if I wanted to reform the education in the academic engineering world, I would put something much more practical.
Yes.
And much more connected to everyday world instead of doing purely mathematics.
Right.
Also because of the interest of the students and
There's a
Cedar Creek Custom Case Shop is your premier fretted instrument custom case maker, and we invite you to create a musical instrument case unlike any other, one that's unique to you. Every Cedar Creek custom case is hand-built by highly skilled craftspeople using only select woods, Prominence Forge hardware, and premium instrument-friendly materials. At Cedar Creek Custom Case Shop, we are dedicated to helping you design the case of your dreams. Find out more at cedarcreekcases.com.
Podcast I like to listen to called Freakonomics. Do you know the Freakonomics Network? There was
No.
an economics book called Freakonomics, which was a very big seller. Maybe it doesn't matter. One of the two writers is an economics professor at the University of Chicago, which is one of the major economics universities in the world, and he's on a mission to rewrite our approach to mathematics, because he really believes that, that there is a better way. Currently, mathematics in education is a bit of always a zero-sum game. You're good at math, you're bad at math. How many times? I don't know about here in Italy, but certainly in Canada and throughout the USA, people say, "Oh, I'm bad at math," or "Oh, I'm good at math." There's
the same in Italy too.
but there's either you love it or maybe you hate it. But it doesn't have to be that way. And school for me was something to get through. It was not an enjoyable place for me. I moved a lot also, and so I had to restart, and I don't remember this being a problem, but the point is, I very commonly, my teachers, I would move to a new place, and then there would be the meeting with the parents. Jamie's a smart boy, but he's not performing well. He's not doing well, or I'd go to high school and I took the general courses, and in the first week my teacher would say, "Why did you take the general course? You should be in the..." But I didn't want to put in the effort, frankly, because I never connected with it. And when my wife found the Waldorf school for our kids, and I saw them drawing a circle, and then a 3 division of a circle, and a 6 and a 7 division of a circle, and then they make the division, and then they draw a lily, or they see a flower or something, and then my kids are doing math in the garden, and my kids are doing math with seashells, and they're talking with the Fibonacci sequence, but they see it everywhere. There's a way to love math. There's a way to make it meaningful, and I hope, maybe I'm too romantic, but I hope this to be the case for my grandchildren, and so on. I think that we can care about mathematics in a way that is missing from a lot of our education. Would you agree, or was your experience different?
I totally agree. During my elementary, middle, and high school, I had some glimpses of what you said. I did the ordinary school here in Italy.
Yes.
Had some glimpses, and that really struck me. It was really beautiful to see all this connection, but we didn't always delve into them. So I totally agree.
As an adult at this stage, I had this adversarial relationship with education growing up, and now I find myself, I teach in colleges and universities as I travel around the world, which is a very fascinating thing, because I didn't even graduate high school. I left high school to start a business when I was 17. I didn't finish, and now I would love it. I think a friend of mine said that education is wasted on the young. I think he's twisting a phrase in English that I think was, "Beauty is wasted on the young," but now I would love to study in a way, and I do. I guess that's what we're doing right now. We're having a conversation. I'll be much more interested in it now. But I spend a lot of my time professionally making understandable complex situations, whether it be language and cultural differences between Europeans and Americans, which is what a lot of my career started with, is helping Americans understand about European product and helping Europeans understand how they calculate their profit margins. I can do some math, and such, because they're calculated differently, but the language is the same. So one will say, we talk about a profit margin, and we'll say the profit margin is 30%. And the European will say, well, that's not enough. And the American go, well, that's standard. And they say, well, not where I'm from. And the thing is, the missing piece is that the Americans are going from the total price and they're deducting 30%. And the Europeans are taking what they buy it for and they're adding 50%. In the end, the numbers the same. Yeah, 50% more, 33% less. You end at the same number. But they were missing opportunities because they didn't realize this small communication difference. And then in more recent times, I find myself part of AI think tanks between a brilliant mathematician and a neuroscientist and the guitar guy, where the mathematician says something and the audience is listening, trying to understand. The neuroscientist says something, the audience is listening, trying to understand. And then I say, oh, what you said ties in nicely to what they were saying there. Do you think that? And the audience goes, oh. Yeah. So this is my attempt to simplify for my own purposes. I find is actually one of my roles now. I've been invited to a number of panel discussions where I go into it wondering why I'm there. A technologies conference, AI discussions, and I'm not a technology or AI person, but I am a conceptual thinker and an abstract thinker.
So you basically see connection between subjects.
Yes.
And try to see what is in common between the two. That's really interesting and also difficult nowadays to see, because everyone is focused on his thing.
Yes. Hyper specialized.
Yeah.
Which allows us to do amazing things. But as we said at the beginning of this conversation, for that astronomical clock to have been built 400 years ago, they had to understand the movements of the cosmos and the movements of a very small gear mechanism, and to cut it with the precision that allowed it to actually function, which is amazing. And so, the thing is, and this has been one of my considerations, and I think that you and I discussed this a little bit over lunch, because there's a professor at the University of Milan and Tokyo, she splits her time between them, who wrote a course on abstraction that I'll be interviewing not so long from now. And this idea of abstraction and the concrete, and the fact that there are some people who really abstract to the point where the average person doesn't see the connection anymore. They don't. How is that related? Right. Actually, my brother, my wife was in the town of my brother a few weeks ago, and she told him that I would be here and that we'd be having this conversation. He's like, what does that have to do with guitars? That's he he doesn't see the connection, but I see that we're both dealing with tensioned objects, and we're dealing with movement in the direction of energy. But I had a problem with someone who was hired with a company, a client of mine, who was extremely concrete and saw everything as ones and zeros, or everything as a commodity, which is a way to see the world, and a useful way to see the world.
One of the useful
ways to see the world. But he calculated me as a zero because he didn't understand that the abstract sort of futurism type of work that I was doing to create a positive future with the company was valuable. Particularly on a sales side, it's very easy for companies to sell their history when they've had successes, rather than continue to put money in research and development, which can look like a big money pit, right? And that R&D is very expensive sometimes, especially in the industry that you're in. I mean, the amount of money that must go into the R&D, the budget for one of these companies is unfathomable for many people, I imagine. But many people will see, especially a second or third generation of a company, the visionary is normally a very good abstractor, the entrepreneur who starts a company. and then the management of company, which often is what allows it to become a super success. Because the entrepreneur often can't do that on their own, get it to the next step. They need someone who's much more concrete, much more organized to take it to that next level. But if that next level does not value the abstract nature of the entrepreneur, then you get into this headbutting scenario. And I've really been considering the best ways to communicate between the concrete and the abstract on the and how to help people see the things that aren't yet here, to help them see the forces of the air, that the air that seems to not exist, as we're discussing. And yeah, I spend a lot of my time doing that these days. I didn't expect it.
Is it difficult?
I don't think so. But that's one of the things I have to think about, is that the person who is able to abstract is mostly able to see the concrete. Some are so disconnected from the ground.
But this is a special case.
Yeah, they're kind of floating away all the time, you know. But you know, those who are able to do it, you know, I'm sure this has happened with you. You know, that mathematics, I'm sure you work hard for it, but a certain amount of that came, you might call naturally to you, that you seemed like you could understand what they were saying, when many of your classmates, particularly in the younger grades, probably were not seeing it.
That's true.
And how do you help someone see the thing that you just see?
It's difficult. You need to understand the person you have in front, and probably you have different ways of showing them what you see, depending on who you're talking with. So I don't think there is also coming back to your discussion, there's no one way to connect the abstract to the concrete. But there are several paths and several ways, depending on the two persons probably who you're trying to connect, if you're talking about persons. And also probably also regarding different subjects, different thematics. There is no one way fixed and defined.
Well, you're quite open, and you defined yourself as someone who's open at the beginning. But when you have an extremely concrete person who sees things as a 1 or a 0, when they determine you're a 0,
there's no way
they
to
don't
go
give any energy. They write you off. You're not worth their time. They can get angry or forced to give a 0 some value. and this is the real challenge, is how to, I guess we're getting into diplomacy at this point. Right? And that's interesting. Maybe I need to speak with a diplomat. This is a good question for a diplomat. I met an international diplomat recently. Okay, that's going on the list.
That's going on the topic.
They would be a good person to discuss the abstraction in concrete episode with. Well, wonderful. Giulio, was there something that you wanted to discuss today that perhaps if I were a more insightful interviewer, I would have already asked you?
Not any specific topic regarding my work.
In general?
In general.
Physics?
Guitars?
Diplomacy?
Diplomacy.
Flowers in mathematics? I mean...
Diplomacy is something that I need to really apply every day at work.
Yes.
In order to have something back.
Yeah. This is a common engineer and not engineer problem. It's the category of engineer. Yeah. Why?
Basically, because, for example, in the car making, every department has its own goal, which is not an economical goal. It's basically a technical goal in which you need to bring in the car something that is working, and most of the times all the requirements from different department clashes. So that's why diplomacy starts to develop and to grow. Basically need to make some compromise. I take something more, you take something less, and that's the everyday job.
Yeah. There's a company from the U.S. called WL Gore, I think it is. W is the first initial. That, Gore-Tex, this performance material. And I think they come from a special group of people. I think the Amish or the Pennsylvania Dutch, this very traditional, and one of the concepts with these Mennonites or Amish is that some of them don't allow their communities to grow larger than 150 people. Do you know about this?
No.
Okay, so they say within 150 people, we can keep the connections, the strings attached between us, and outside of that, we lose accountability. We, like someone in the street, you can, flip off. You can say something nasty to them that you wouldn't say to someone that your neighbor, in the same way that and so when these communities get to 150 people, they actually split them, and the community will help raise the barn and a few of the buildings together to help start off the seeds for the next community, and they split them until they hit 150 again, and they grow out. And the W.L. Gore Company believes so strongly in the power of keeping it below 150 people that although their company has grown beyond 150 employees, none of their facilities have more than 150 employees. So there's a long road of many smaller buildings, which has some inefficiencies. But within that segment, if the salesperson is wondering why we're not shipping the order, well, that person goes down and talks to the person whom he knows by name and talks to them, and they say what's going on, and they talk to the other person they know, and they communicate. So it's not this feeling of the higher up powers or the different people that are unconnected and human. And so,
but do these different buildings have different departments in them? Or is it sales department in one building? Is it R&D?
No, I don't think so. So I think that each division is somehow brought together within 150 people. And so the manufacturing, and maybe that there's a sales for that product, and there's a shipping for that grouping of products. So, the reason that I'm more familiar with the W.L. Gore Company is because they took their material and they applied it on the guitar string and started a company called Elixir Guitar Strings, which these strings lasted 3 to 5 times longer, and they were a little more smooth. There's less resistance on them, and so I suspect that division has less than 150 people in it. So I read about it in a book, I think possibly by Malcolm Gladwell, who tends to sort of look at a situation which is commonly known as one way and give you a different way to understand it. And I think it was one of his books. Don't quote me on that, but I think it was in a Malcolm Gladwell book. And I just, whether it's true or not, I think that the concept is interesting, and that we can certainly recognize that a smaller group of people is more accountable to each other, and that you make more of an effort to have some diplomacy. And when you have a problem, you can't get away from each other in the same way. So you have
try to find a way.
You have to try to find a way. You can't ignore them.
Yeah, that's right. Interesting.
Yes. Yeah. And so one of the amazing things about globalization, although we often talk about the negative things of globalization, is that we learn the ideas of other communities. And although industry is certainly not something we attribute to the Amish or the Mennonites, this community we do. And so now when we take community and industry and we synthesize the two together, maybe we get a more humane version of industry where we have a better quality of life and treat each other well. Yeah.
Inspiring.
Yeah. Well, maybe something to check out and to take back to your own life and work.
Yeah.
You know, one of the core concepts of what we do is that we're better together. I rely on partners all the time.
Yeah.
And I rely on the generosity of people like yourself, who I'm not sure what you're going to get from this,
Oh, it was,
but I appreciate that you were willing to sit down and have the conversation with
it
me.
was really, really interesting for me. I got a lot.
Good. So, thank you for being on Life with Strings Attached. I've really enjoyed our conversation. I certainly hope it's not our last one. I look forward to,
Yeah, for sure.
you know, I'll be ruminating on the things you talked about. Air separation, I'm going to be studying that. I'm going to
Okay.
understand that a little bit
That's
better.
the main topic of Io.
Yes, and these small vortexes. You said what it was. I'll look at the recording, and I will take a dive into these topics also, and find a diplomat to interview.
Thank you very much, Jimmy.
So,
It was a pleasure.
yeah, thank you, Giulio. Is there anything else you want to say, sort of in closing, or anything else?
No.
Okay.
Fine.
Well, thank you very much.
Thank you very much.
All right.
Thank you for watching and listening. You can find more episodes wherever you listen to your podcasts. And a special thanks to those who support us on Patreon. It's your support that enables us to do this work.